Okay, the idea of this video is to give you the minimum on force so that you can understand the problems and do the problems in section 10.2 and even extend it to sections 10.3 and 10.4 when we talk about work and torque, okay? I know that most of you know these things. That's why I'm recording a separate video. But long story short, what is force? Well, force, according to Newton's second law of motion, force is equal to mass times acceleration. Then no surprise that the units are usually newtons, okay? And what is a newton? A newton is 1 kilogram, right, mass times meters per second squared, which is acceleration, okay? So, well, that's that with that. So let's see. So we know that force is a vector because it has, right, like if I'm applying a force in that direction, well, that's the direction. And then this is my force vector. And then how much of that force am I applying will be the magnitude, which you know that I use the double bars to refer to magnitude. Now, sometimes it's helpful to think about this as the sum of the vertical and horizontal components of the force. So mathematically speaking, what I'm saying is, well, since this is a vector, I can write it as the sum of two vectors, and I'm gonna go like this. So it makes sense, right? So I'm doing here head to tail so that you see what the sum is. But long story short, if I call this purple one, right, this is going to be my x component, the same as saying the horizontal component, and then the pink one is the vertical component, then I know that my force, the force vector, using math actually, can be written as, well, the x component or the horizontal component plus the vertical component or the perpendicular component, okay? Or the y component, whatever you want to call it. Now, how do we define these things? How do we find these things? Okay. Now, if I take my vector f and I put it on the x-axis, right? Let me just take this with me, copy, and put it on the Cartesian plane. So this is my Cartesian plane. And I take that same diagram and I put it here, okay? Then I know that, or we see that, the vector f, it's making an angle of, let's say, theta with the x-axis. Once I realize that, and I realize that these two vectors are perpendicular, then I know that they form a right angle. Well, I have everything I need to find what these components are, okay? So first of all, now that I know what angle we have, then we know that f has to be equal to, well, the length of this vector, and then the location is going to be given by cosine theta sine theta as usual, okay? So this is going to be cosine theta sine theta. Perfection. And then if I know that, if I want to find what the others are, then it's enough to notice that we know that cosine theta, it's equal to adjacent over hypotenuse, the length of those. So this is going to be the length of the adjacent side divided by the length of the hypotenuse, which is just the magnitude of the vector f. So from here, we see that then the magnitude of the vector fx, the x component, the horizontal component, is just the magnitude of f times cosine theta, okay? And then since this is on the x-axis, that means that cosine 0 is equal to 1, sine of 0 is equal to 0. So that means that the vector, the x component or the horizontal component is just equal to, well, the length of the component, which is just the length of f cosine theta. So this is going to be the length of f cosine theta times, and then the vector is just the vector 1, 0. And then same way, we can find, we know that sine theta is equal to the length of the opposite side, which in this case, right, opposite will be the length of the vertical component, divided by the length of, I keep saying length, magnitude, the length of F. So from here we get that the magnitude of the vertical component, it's equal to the magnitude of the vector F sine theta in this case. And we know that this point over here, right, the location of this, if I take this and I put it on the y-axis, it's just 0, 1. So I put that together and I get that this is equal to the magnitude of F sine theta, and then the vector is 0, 1, okay? So as a result, I can write this like that, or I can write it in using the basis. So you can also say that, we can also say that the vertical component, the horizontal component, or the x component, it's equal to the magnitude of F cosine theta I, right? And then the vertical component, or the y component, it's equal to the magnitude of F sine theta j, okay? And then again, that brings me back to the fact that my vector F, it's equal to the horizontal component of the force plus the vertical component of the force, and this is how you can find them, and this is why they are defined like this, okay? All right, I hope it makes sense.